Inverse functions. The word inverse means something that is opposite or reverse of something else. We've been using inverse operations every time we try to solve for a variable in an equation because we use the opposite to cancel out. Today we're going to learn about inverse functions. Here are two examples of inverse functions. So we have f of x is equal to the square root of x minus 4 over 5, and g of x is equal to 5x quantity squared plus 4. These are examples of inverse functions because inverse functions have opposite operations of the original function. For example, you see how we have a square root in f, but a square in g. We have a minus 4 in f, but a plus 4 in g, and then we are dividing by 5 in f, and we're multiplying by 5 in g. The domains and range values are reversed for the inverse function from the original function. So these guys are just opposites of each other. And the function notation for inverse functions is seen below. And the way we pronounce this combination of symbols is the inverse of f of x. It's not f to the negative 1. This is pronounced the inverse of f of x. How to find the inverse functions? Since the x values and the domain values, the x and the y values are reversed, all you have to do is switch the x and y in the function and then solve for y. So we have y equals 1/2 x minus 7. Switch the x and y's. And then you're going to do opposite operations to solve for y. So you add 7 to both sides, and then you need to multiply by 2. Your final inverse function is 2 parentheses x plus 7. There's really no need to multiply through by the 2 because it's a lot easier to see that the opposite operations are in there because we can see the positive 7, the minus 7, the multiply by 2, and the divide by 2. So again, no need to multiply through or simplify. The next example we have is y equals x squared minus 1. So we're going to do it the same way. We're going to switch the x and y values and solve for y. So we add 1 to both sides. We take the square root. The inverse of f of x is equal to plus or minus square root x plus 1. You need the plus or minus symbol whenever you take the square root, otherwise your inverse will be missing half the function. Because when you take the square root, it only accounts for the positive values, and we need to account for the negative half as well. So don't forget that plus or minus. How to graph inverse functions. First thing you're going to do is set up a table of values for f of x. You get to choose the appropriate values that you would like to plug into your function. It's going to be different for every kind of function you have. For this one, I know I have a parabola, and I know my axis of symmetry is going to be the y-axis, so I just picked values between -2 and +2. Plug them into my function. Step 2 is to switch the x and y values to make the table for the inverse. So we have the inverse function as plus or minus square root x plus 1. I'm not doing any recalculations here. All I'm doing is taking my y column and turning it into my x column for my inverse function. And then my x column turns into my y column for my inverse function. So again, no recalculations. I'm just moving the two columns. I'm switching the two columns. The next step to graphing is to plot the points and create the graph for f of x first. So here's our parabola. Axis of symmetry is the y-axis. The vertex is at 0, -1. And then I'm going to plot the points and create the graph from my inverse table. So those points plotted here are from my inverse table. The final step is to plot the dotted line y equals x. So y equals x is a diagonal line that has a slope of 1 and a y-intercept of 0. And we need this line to make sure that we graphed all of our points correctly. You'll know if you did it right if it's symmetrical over the line y equals x. These guys are perfect mirrors of each other over the line y equals x. We're going to run into some situations where our inverse function is going to have some sort of domain restriction, specifically whenever we deal with square roots. So we have f of x equals square root of x minus 2. For this function, we know that the radicand cannot be negative, so the numbers x is greater than 2 make up the domain. The result of a square root cannot be negative. There's no way we can take a square root of a number and it to be negative, so that means all of our range values are going to be greater than 0. So if we find the inverse for this function, first step, switch the x and y values, and then solve for y by squaring and adding 2. So our inverse function is x squared plus 2. Since the original function has a domain and range restriction of x is greater than 2 and y is greater than 0, the inverse function has a domain restriction as well. So x values have got to be greater than 0, and the y values have got to be greater than 2, because the original domain applies to the inverse function. So if you have a restriction, so pay attention to those square root problems, then the domain restriction needs to be included in your answer. So there it is, it's for all x values greater than 0. What you're going to do now is for each problem below, you're going to find the inverse of the function. You're going to graph the function and its inverse, so you're going to have 3 separate graphs. And if you have any domain restrictions, you're going to state them. I'll give you a hint on problem number 3. Be strategic when choosing your x values for the table. You do not have to use consecutive numbers. So that means if you use numbers in a row and it's just not working out for you, you're allowed to skip. Make sure you pick x values that you can calculate without a calculator. Take a picture of your answers to these 3 questions and submit them to the assignment on Schoology to receive credit for this assignment.